Okay, you guys, so for my setup here, I have a clear container of water. The water is at room temperature, okay? I have a pot over here of hot water. I have a jar that I will be pouring the hot water into and a pipette to transfer the hot water into my salt shaker here. This is an empty salt shaker. I'm using this, but you can use any small container that has a small opening. So I was thinking maybe a travel sized shampoo bottle or some sort of small, preferably plastic bottle with a small opening. You'll see why. This is the only container I could find that worked. So I ended up using an old salt shaker. If you have an empty spice container with an opening like this, then you can use that as well. I have some red food coloring. And over here, you'll see behind my container of room temperature water, I have some ice cubes. And the ice cubes are actually dyed blue. Okay, so let's play and see what I'm going to do. So there's my blue ice cubes. So I'm taking my hot, very hot water, and I'm pouring it into this jar. And then I'm taking my red food coloring and dropping about 5 drops into my small container here, my empty salt shaker. Okay, so my food coloring is in the container, and I'm using my pipette to transfer the hot water into my empty salt shaker. I have to use a pipette because the opening is too small for me to pour the water. If you use a container and the opening is big enough for you to pour the water directly into the container, that's great. Mine was just too small. So I'm transferring it using a pipette. Okay, so you can see it's taking me a while because the pipette can only pick up a little bit of water at a time. All right, friends, so remember what I said. We're going to see. Okay, so before I say what I was about to say, you saw that I closed the container and I swirled it around to mix in the food coloring. So now I have my hot red water in my small container and I have my blue ice cubes. So remember, we said we were going to demonstrate that hot air, and in this case, hot water, weighs different than cold air or cold water. And when we talk about liquids or we talk about air, usually we use the word dense. We say cold air is more dense than hot air. Now, density, just a fancy word that talks about weight, talks about how much liquids weigh and how much gases, or in our case, air, weighs. Okay, so I'm going to use the word weighs or weight, but I'm really talking about this big word called density. Okay. However, I know that we've talked about weight before, so I want to keep using that word. So we said that we're going to see hot air, hot water, weighs differently than cold water. So that's why I dyed my hot water red and my cold frozen water blue. So when I go and I drop these into remember this is room temperature water, we're going to see one of them rise and one of them fall. And if you remember what I said earlier, you'll see which one does which. So I'm dropping my blue ice cube in, and then I'm going to open the cap on my salt shaker and let the red water pour into my room temperature water. And what do we see, friends? We see that my blue water is immediately, right away, sinking to the bottom of my container here. And my red water is staying on the surface, on top. I had to help my salt shaker here because it was starting to sink a little bit. So, friends, the reason why you want to use a small container like this is because you want to open the cap and let it float on top. And while you let it float on top, the water will start to spill out. If you simply take a container of hot red water and pour it in, it's going to happen too quickly and everything's going to mix together and you won't see these separate layers here, okay? That's why you kind of want to let it pour out nice and slowly, and then you'll see that it stays at the top on the surface. Okay, so remember I said that our cold water is going to sink and our hot water is going to, I said the word rise. I said it's going to stay on the surface. Okay, and that's exactly what we see here. And you can even see the cold water melting from our ice cube here and moving down to the bottom of our container. And our red water is simply staying on top because our blue is cold and our red is hot. And we're going to see the same thing here. I'm going to go ahead and do it one more time. And I want you to watch how our ice cubes start to melt and watch what happens with our red. So at first you can see I poured it in a little too quickly. But friends, if you look right here at the red water, it's moving toward the surface, toward the top. It's moving up. Do you guys see that? These are moving up. And the blue, look at the blue water coming out of the ice cubes. It's traveling down. So you can see I'm having to hold my salt shaker and help it a little bit here, but I'm being very gentle and I'm pouring out the red water very slowly. So we see our two layers. Our red is staying on top and our blue is staying on the bottom. And again, why is that happening? Well, we said cold water weighs more. In other words, cold water is more dense than hot water. Hot water weighs less. Hot water is less dense. So just like when we use an object, like our egg or orange, and we see it float or sink depending on how much it weighs. Well, you can think about it in that way here too. You can say, well, our blue water is sinking because it's heavier than our red water. So our red water is floating or staying near the surface. It's staying on top. In other words, our blue water is heavier than our red water. Our cold water is heavier than our hot water. Okay, and the other word I used was our cold water is denser, more dense than our hot water. So it sinks and our hot water floats. And you can see as the ice cubes melt, you can see the water moving downward, immediately going downward, and they don't even mix. They're staying separated because our red water is significantly hotter. It's way hotter than our blue water. Blue water is cold. I want you guys to watch one more time. Side note, I actually tried this a couple times before this video, and you have to use a lot of food coloring. If you don't use enough blue food coloring, then when you put the ice cubes in your container of water, you won't be able to see the blue. It blends in with the water too much. So you have to make your ice cubes super dark so that you can see the blue water moving. Same with the red. If you don't use enough red food coloring, then you won't be able to see the layers as well. Okay? So don't be afraid to use a lot of food coloring. We can be generous in this case. It helps us see it way better. So again, friends, we're seeing our hot water rise to the top and our cold water sink to the bottom. Just like I said with air, hot air rises, cold air sinks. Same with water. Our blue, cold water is sinking. Our hot, red water is floating or staying on the surface of the water. And it's important to use room temperature water because we want there to be a difference in temperature. We want the hot water to be a lot hotter than our container water, and we want our ice cubes to be a lot colder than our container's water. Okay? So super cool demonstration here. The same thing is happening all around us with air. The hot air is rising and the cold air is sinking. But naturally, we can't see that because air is invisible. That's why some food coloring is super handy for these demonstrations, because we can see firsthand. Cold sinks, hot rises. And again, why is that? Because the cold water is more dense than the hot water. Or you can say the cold water weighs more than the hot water, so it sinks. And again, friends, this is very similar to our oil and water demonstrations. Okay, we said the water was heavier than the oil, so it sank. We can also say the water is more dense than the oil. So the more dense liquid, the more dense item, the heavier item sinks. Same with our saltwater tower, right? When we added more salt to the water, it made it heavier. And that's why, in our example, the blue salt water went on the bottom because it was the heaviest. Another way to say that was the blue salt water was the most dense. And in our saltwater case, the red salt water was the lightest. It was the least dense, so it went on top. Same thing. So for liquids and gases or air, we use the word density, dense, instead of weight, but very, very similar concept. All right? So there you have it. A first-hand demonstration that heat rises and cold sinks.